Here is a test problem for you. It's based on application of laws of logarithms. Write y as a function of x and then state its domain. The function given to us is log of y plus 2 equals to log x plus log of y plus 1. I'd like you to pause the video, solve the question, and then look into my suggestion. Okay, let's solve this question. Log y plus 2 equals to log of x plus log y plus 1. When we say write y as a function of x, we basically want to isolate y. So let's bring the y terms together and then see what happens. So taking log y to the right side, you will understand why I'm taking it on that side just in a minute. We have 2 here, and I'll bring log x to the left side. Minus log x equals to log of y plus 1 minus log of y. Now all the terms on the right side are in terms of y. Using the logarithmic laws, we can combine these two terms, write them as quotient, right? So the right side becomes log of y plus 1 divided by y, correct? That becomes the right side. How about the left side? Could I write 2 as a log of something? This is to the base 10, right? Let me go one more step. I could actually write 2 as log 10 to the power of 2. Is it okay? 10 square 100, that is 2, right? Minus log of x. That's kind of tricky. Now, we can write on the left side as log of, we can use the laws, correct? 100 divided by x equals to log of y plus 1 divided by y. Do you see that? Now, both the logarithms, we can equate 100 over x with y plus 1 divided by y. So we get 100 over x equals to y plus 1 divided by y. Now if I divide this by y, what do I get? I get 1 plus 1 over y, and on this side we have 100 over x. Now I think it's easy for us to isolate y, correct? Let's do it on the right side. So what we have here is 1 over y is equal to 100 over x minus 1. X minus 1. So which is equal to 100 minus x over x, that is 1 over y. So what is y equals to? So we can write y is equal to x divided by 100 minus x. So that is how we get the function y in terms of x. Do you see that? So that's kind of tricky, and I hope you find it very interesting. Now let's do the second part, that is state domain of this function. Now domain should be, as you know from here, x could be all numbers, but x is not equal to 100, right? So x belongs to, so domain is x belongs to real numbers, where x is not equal to 100, right? So that becomes the domain for this function over here, right? Now remember one thing, that if you look at the function, we have log x. Remember, in the function we have log x, so x cannot be negative, right? Otherwise this function will not be true. And therefore, it's a good idea to introduce that also within the restrictions, right? So the domain, since this is derived from the given function, right, will have this restriction also over and above what we get here, correct? So the domain really is x is greater than 0, right? X cannot be 0 also, and x is not equal to 100. So the domain will have both restrictions. The restrictions from the source, and then what we finally get, right? So here we know denominator cannot be 0. So that adds to the restriction, and this is from the source itself. So x has to be greater than 0, and x cannot be equal to 100. So that is the restriction, right? The function would, however, be equals to this, and it's a good idea to write here as x is greater than 0, right? Since we derived it from logarithmic function, correct? And where x value cannot be negative or 0, right? It has to be positive. So that is our answer for the given question. Go through it once again, try to understand how we got this solution. I hope it helps. Thank you and all the best.